So let's just see how we can delete the last node of the circular singly linked list. So here we have the circular singly linked list with 3 nodes. So let's now see how we can delete this last node from the list. So to delete the node, we have to follow this algorithm. So first of all, we have to check if the list is already empty or not. So if the list is empty, if the head is null, so that means there is nothing to delete. We can just simply return null. Otherwise, we have to check if there is only one node. That means if the head next is pointing to the head itself, so in that case, we're just gonna free the node and we're gonna return null, because after deleting one node, nothing will be left in the list. And thirdly, if we have multiple nodes, so in that case, we have to go to the second last node using one loop, and we have to delete the last node. So we have to free the memory allocated by this last node, and also we have to update the pointer. And at the last, we can return the new updated head pointer. So currently we have 3 nodes in the circular linked list. So here we're gonna write the function to delete the last node. So the function will return one struct node type pointer. So we're gonna call the function delete last. So the function will take struct node type pointer head. Now inside the function, first of all, we have to check if the list is empty or not. So the list is empty, that means the head pointer is pointing to null. So here we can check if the head is pointing to null, that means the list is empty. So in that case, you don't have to do anything. We can just simply print list is empty and we can return. Now in a case where we have only one node, so suppose we have only one node in the list, that means the node will point to itself. So here we're gonna check if there is only one node in the list. So we can check that. So if the head node's next pointer is pointing to the head itself, so that means there is a self loop which indicates that there is only one node in the list. So in that case, we can just free the memory and return null. So here we're gonna free the memory allocated by this head node, and then we can just return null. Now suppose we have multiple nodes in the list. So in that case, if we wanted to delete the last node, we need to use one temporary pointer which will initially point to the head. So here we're gonna create struct node type pointer temporary which will initially point to the head. And now we have to traverse to the second last node. So we have to use the loop to move this temporary pointer to this second last node. So we can use the while loop. So the loop will continue as long as the temporary pointer's next node's next is not equal head. So here we're gonna check if the temporary pointer's next node's next. So when the temporary pointer's next node's next is a head, that means we are pointing at the correct node which is at the second last node. So we have to reach till this node. And in each iteration, we're gonna shift the temporary pointer to point to the next node in the list. So when this loop ends, our temporary pointer will point to the second last node. And now we have to free the memory of this last node to prevent the memory leaks. So here we're gonna free the memory allocated by the temp next node. So that means we are deleting the last node. So now we have to set the link from the temporary node to the head node. So here the temporary node's next pointer should point to the head node, and we can return the new head node after the modification. So here we can check that. So currently we have 3 nodes in the list. Now we can call the function delete last node, and here we can pass the head pointer. So this will return one new head pointer, and we can print the list again. So you can see initially we had 3 nodes. After the deletion, the last node 300 is removed from the linked list. So this is the way we can delete the last node of the circular singly linked list. So hope you understand the concept. See you in the next one. Take care.